Welcome to the Masters of Engineering podcast. Cool products, the people who develop them, and how they do it. I'm your host, Jon Hirschtick. I've spent my entire life building CAD systems, but the best part of my job is I get to meet some of the coolest product developers on the planet. And in this podcast, you get to meet them too. My guest today is Mark Sanders. He is a principal at MAS Design, which is his company, and really one of the coolest bicycle developers on the planet. He is kind of the father of the triangular bike. He's made folding bikes of note, and he's the only person I know to have his designs exhibited at both the Museum of Modern Art in New York City and the Smithsonian Cooper Hewitt Museum, also in New York City. In fact, he's the only person I know who's had his work exhibited in either of these museums. Mark, welcome to the podcast.
Thanks, John. That's a great introduction and lovely to see you. It's always a pleasure to see you. Usually in the UK at one of the Develop 3D Live things and places like that. But real honor to be here. Great to chat.
Well, it's great to, and this is the fun of doing the podcast for me, is it's just great to see you and talk with you. And yes, we met, if I recall, at the Develop 3D Live conference in the UK. And I remember talking with you and being struck by just what an interesting product developer you are, just what an interesting designer and developer. Start right off, you've designed a lot of things, but most notably, you say triangular bicycles. I said, as we were preparing in our discussions, I said folding bicycles, but you said triangular bicycles. Tell us about the bicycles that you've designed.
Yeah, well, I suppose my most famous one is a triangular folding bike called a Strida. And basically, it was my college project when I went back to college and needed something which fulfilled both the requirements of Imperial College, which is an engineering college, and the Royal College of Art, which is a design college. And at the time, I was commuting 22 miles from Windsor into London. And I tried the bus, which got into congestion, the train, which wasn't door to door, cars went in congestion. And so I thought, hey, a design for myself, why not a bike? And so this product developed as a college project. And the core to it was, it's just 3 tubes and 3 joints. And you just fold the 3 joints into a stick. So it's a stick with wheels when it's folded, or it's a triangular bike when you ride it. And it's been going for 30 odd years. It's still in production and sells mainly in the Far East. It's been copied quite a lot, but the main, original version is still for sale.
Well, I suppose copying is a form of flattery. It's not good, in terms of intellectual property. But you've told me that folding bikes were around a long time before you designed the Strida, right?
Oh, yes. I mean, folding bikes go right back to World War I, when parachutists used to, jump out of planes with a folding bike on their back, because it's such an efficient way of, you land, you unfold your bike, and then you ride out of the danger zone or wherever you're trying to get to. And it's a perfect thing to combine 2 forms of transport. And in that case, it was an aeroplane plus land use.
That's really amazing. So I didn't know they went back to World War I. And what a moment. I think of someone brave enough to jump out of a plane with a folding bike strapped to their back, really amazing human courage. But if the folding bike already existed for what might be 50 years or more, before 50, 60, 70 years before the Strida, what were you trying to accomplish with the Strida?
I suppose it was a fulfillment of my core philosophy, which is basically simplification. Because if you can simplify a product down to its absolute minimum of components, it has benefits all the way through. There's the BOM cost is lower, there's less tolerances to stack up, it's lower cost to make, easy to fix, less to go wrong, etc., etc. And that philosophy has kind of followed me through my career, and I still really believe in it. I mean, Colin Chapman, another hero, the Lotus guy, used to say, simplify and add lightness, and that applies to so many products, you know, and especially bicycles.
Simplify. What's that? You said simplify what after
And
that?
add lightness.
And add lightness.
Yeah.
Simplify and add lightness. Well, and that lightness, if I may say, is, as you were alluding to, it's a lot of lightness. It's of course physical weight lightness, but it's also just lightness of concept work, assembly, maintenance, right? Of many dimensions, even of the end user's perception.
Yes.
Yeah, and too many products today are heavy to engage with. And I'm really interviewing you about design, but I'll make my own comment. Too many products force me to have too complex a relationship with them for the value delivered, particularly software products, I think. Like
Yes.
I just want to do something simple, and I'm forced to create an account and log in and click and read and all this. And yeah, I'm reminded of a book I love by an author you'd love to meet. There's a book called "Don't Make Me Think" by Steve Krug. It's about designing web pages. I have to get Steve on the podcast. But anyway, he has a chapter in there, Mark. You'll appreciate it. His chapter is called "Eliminate Unnecessary Words," and the word "unnecessary" is crossed out. Like eliminate, and I love that. And that's stuff. So you were a believer in simplifying. So you looked at, did you know the existing folding bike designs? Did you would use them? You had seen them, and were you frustrated with them, or did it break down, or what really you wanted to simplify? But was that born of a personal episode?
Yeah, basically I tried them all, and they're either very heavy, which, when you're carrying it on the train, you don't want something heavy, or complex, or they had oily chains, which you don't want to get on your clothes, things like that. And so this thing is clean, it's belt drive, so there's no oil or grease. And at the time, we're going back 30 years, people said, you can't drive a bicycle with a belt, it'll never work. But funny enough, now it's a common thing, and the benefits have been realized. Belt drive bikes are really good because they're clean and they last forever, compared with the chain, which needs grease and picks up, grit and then wears out and all this sort of thing. A belt just lasts. That's why Harley Davidson use them.
Oh, really? Well, belts do wear out, right?
Well, funny enough, on a bike, what happens is it's not the belt that wears out, it's the pulleys, because the belt,
really?
Yeah, it's got rubber teeth. And so the rubber absorbs the little pieces of grit, but then the grit actually wears against the plastic or aluminium pulleys. And so the first thing you need to change after, 100,000 miles are the pulleys, not the belt.
100,000 miles.
Well, it's the same as a car camshaft drive. Yeah. So,
but people don't ride their bikes 100,000 miles. No. Okay. All right. So
we've never changed a belt due to it wearing out. Put it that way.
So, lots of people have great designs and even great projects when they're in school. And so this was your thesis or school, a university project, right? College project. But the story of Strida is notable because it wasn't just a school project, but it became mass produced in volume and has gone through this interesting history. Tell us the story of getting it from a design at university into a product used by tens, hundreds of thousands, maybe millions of people over the last 3-4 decades.
Yeah, well, at the time, I'd gone back to college as a mature student, age 23, to study a combination of engineering and industrial design. And I needed a major project that covered both those areas. It's a continuum between hardcore engineering and very soft sort of industrial design. And the course was aimed to cover that whole continuum. And that's what fascinates me. The fact that design is not just engineering, and it's not just user friendliness and appeal. It's the whole lot, which is pretty complex. Anyway, a bike fitted both colleges' requirements. It had to work, be innovative engineering and also innovative design. And so for me, it was a perfect project for commuting on as well, from personal point of view.
But how did it go from being a project to being a product that was made in volume? And that's because I know a lot of people design things, even in college projects. There are many good products, but they know very, very few great college projects turn into real products, as you've done.
Well, one of the things I learned at the Royal College was that artists don't normally have an income stream. So they have to do a lot of PR to get themselves noticed. Now, for a guy with an engineering background, doing PR and self-promotion is kind of like a bit of anathema. You don't do it. You don't big yourself up as an engineer.
Right.
So I learned that PR was kind of essential, not for me personally, but to get the product noticed, to move it on to the next stage. And it was a perfect platform because the RCA always have a really good degree show. And so a lot of people from the press and TV come to the degree show. And I cottoned onto that, and I was ahead with the project. So I managed to put lots of PR messages out, come and see this new triangular bike. And it got into the Sunday Times and some, Sunday magazines and places like that, which attracted potential manufacturers. And one of them was a really interesting chap who was a serial entrepreneur, who was actually an early manager of Greg Norman, the golf guy.
Oh,
yeah. And he a really good negotiator and a serial entrepreneur. And he saw this product and he saw the potential in it. And so he said, right, let's form a partnership. You do the design and engineering and I'll do the business side. And that's how the product started. And together we worked on it and got it into production. And it was an uphill climb because at the time, as I say, people said, you can't ride a triangular bike. It's all wrong. And you can't have a belt drive either because you should have a chain, because the bicycle world is very, very traditional. The bike's been designed 100 years ago. So if you rock the boat and make anything different, you get a lot of flack. I mean, this was before mountain bikes came, which was a major kind of change in the bike world. And so, but I persevered and we did well with it. It still ruffled a lot of cycling people's feathers because it was designed not for doing hundreds of miles on, but for connecting other forms of transport. It fits in a car boot or a trunk. You take it on the train, you wheel it down the corridor. You don't have to carry it. And so it actually found its own niche. And it's the ownership of the company has changed hands several times, but it's still going,
So it's still going today. So today people are buying, someone on earth is probably buying a Strida, many people today, and riding it. Well, how many people might be riding it today?
Well, I would say there's probably made about 100,000 in total. They make about 10 or 20,000 a year. In Taiwan, it's a brand owned by a huge, great Taiwanese OEM manufacturer who make for all the big brands. And this is one of their own brands. So because they can't show their other work because it belongs to other people like Cannondale and all those kind of guys.
Sure, I see.
So they have this as their own brand, and so it gets a little bit of promotion in a Taiwanese OEM way.
I think it's awesome. And just going back to something you said, I just want to underline, because I think it's so true what you said about how people told you were crazy. Triangular shape, belt drive. Who's gonna go for that? And you, like a lot of great designers, you persevered with your vision. Entrepreneurs are like that sometimes. you have to proceed. You have to keep going, even when a lot of people will tell you no, you know. And I think most great products, do that in one dimension or another. But I want to also ask you, the design has evolved. Through many iterations, right?
Oh yeah, yeah. It's
Today's
now
Strida.
up to about Mark 5, and
Yeah.
it's had tremendous input from the people that own the IP now. You know, they're right at the heart of the Taiwanese bicycle business, which is kind of like the main innovation area on bicycles. Bicycles are made in Taiwan and China, even if they might be designed in the West.
Well, they're not all made in Taiwan and China. We have some great customers that are making them in other places, and even, I believe, still in the United States in some areas. So anyway, but we could get into that. I wanted to also ask you. Let's see. I wanted to mention. Okay, a cool moment for you. How did it feel when your work got chosen? When the Strida was at the Smithsonian Cooper Hewitt Museum, in the exhibit they had. What was that like for you to be chosen for that?
Oh, that was awesome, because it was the exhibition, if you remember, was all about usability and ergonomics. And that's the thing about the Strida, which was always its benefit. Its users loved it, even though traditional cyclists thought it was a bit weird. And one of the pictures they used, which was the classic Henry Dreyfuss picture of an ergonomic man riding a bicycle. And when you superimpose that on top of the picture of a Strida, which they did as part of the exhibition, he fits perfectly. What's tended to happen in the bicycle industry generally is it's sports bikes have become the kind of the dominant kind of shape, where people lean forward like that. And whereas for everyday riding, a more upright ride is better for your back and for seeing traffic and that kind of thing. But the bicycle industry generally, it is changing, tends to focus on the sports riders rather than everyday riders.
Hunched over, yeah. I could talk to you all day about Strida, but you've worked on other products. Can you talk about a couple other things that you've designed that you're proud of?
Yeah, I mean, I have basically two strings to my work. One is bikes, which I love designing because they're so visceral. Bikes, folding bikes, e-bikes, that kind of thing. And the other side is more things like kitchen gadgets and even hospital equipment, more human-focused things. And I suppose the most useful ones are things like automatic can and jar openers, which have been great fun. They've always been a really interesting challenge. The challenge for an automatic jar opener is not only can you make this thing that you automatically put on a jar and walk away and it opens it, even if the jar is so tight that a strong man can't undo it. But not only that, but it must cost $3.50 manufacturing price. Now, it's easy to design something to solve the mechanical problem, but it's much harder to make it for that cost and also to work reliably. But I love that challenge. The challenge of making something that looks good, is affordable, and actually works and solves the engineering problems.
Well, I looked online and I saw on Amazon your can opener is still being sold, I believe. And I'm sharing a screen. We can bring up. This is your design, right?
Yeah, that's right. Well, that's the can opener, and then there's the jar opener called. Somebody came up with a brilliant name. We call it the Robo Twist. In other words, robot twist.
Robot twist. Okay.
Yes. And again, that was a tough product to design. And what was fascinating about that, I wanted to change the image of both can openers and jar openers. Before, the kind of bent bits of metal with lots of sharp corners and things like that. And my aim was, imagine if you could make a a can opener, which was so friendly, you could rub it against the side of your face and it wouldn't scratch you. And going back, 10 years when there were all metal gadgets with sharp corners, that would be impossible. But why couldn't a product you hold in your hand and you use to open cans be smooth and functional? And so that's how it started. And it was a great product. That is one that has sold millions.
Yeah, the jar opener. So here I'm bringing that up. That's also on Amazon. And, I was just thinking, I got to order some of these for, I know some people who was just at someone's house the other day, a younger person, and I brought over something to eat, and I wanted to open a can, and they didn't have a can opener. So I'm going to get them one of yours, I think. Yeah, it must be great. So these products, very different than a Strida, right? But for you, I hear the enthusiasm that you speak of them with. That's really cool. So you're excited about these too. And the challenge, you said $3, $4 manufacturing cost, huh?
Yes.
Yeah. Wow.
Because, there's so many people in the supply chain, the downline. Sure. So the distributors, the shippers, the distributors in the country, the retailers, everybody needs to make their share. So that's why I always believe that if you can get a really low BOM cost, everything else after that is positive, because you can afford to either sell it to be affordable so that lots of people can buy it and benefit from it, or you can add a margin to help with your, the business margins of the product. But getting something, put it this way, it's much harder to design, for example, a Ford than a Ferrari. Because, it's so easy to just throw money at a product until it works. And that's what fascinates me. It really fascinates me that if you spend time working on simplification and making each part do 10 different things and all come out of one tool, it's just a fascinating challenge,
Yeah. Well, I can relate to that with and I don't want to talk too much about CAD software, which is something we do talk about. But when we designed Onshape, we wanted to have we wanted to go for simplicity too. We wanted to have a simpler user interface. A lot of times people confuse that with less power. They're like, well, you're missing tools. No, we're not. We just put them in a more elegant set. We also turned down the complexity in the user interface. There's a lot less distracting colors and iconography and all that. We just said, let's put all that on a diet and make the aesthetic informed, I think, by things like the Google search page, as opposed to the old heavy applications of CAD. It's very easy breezy. Mobile apps informed us quite a bit. And so we went for a simpler look. And I can really relate to that and in software as well as hardware. I wanted to also touch on your early career background. We didn't get there yet, if I may move on.
Yeah, sure. I'd just pick up on one word you used there.
Yeah.
You used my favorite word.
Oh, really?
Yeah, you did. The
what
word
was that?
Elegance. Elegance applies to everything from engineering to coding, but it also applies to things like music, design, art. It covers the whole continuum of product. And so you can say to someone who is a pure designer, that's a really elegant design. You can also say to someone who's a hardcore mechanical engineering, that's a really elegant piece of design, or even an elegant piece of maths. It's a beautiful word. Love it. So I'm so pleased you brought that up.
Oh, okay. Yeah, well, we strive for
software.
It. Design is design, and now let me go back to maybe where some of that elegance passion came from. Your early career, you were at Rolls-Royce, right? Early on as an apprentice.
Yeah. At the time, it wasn't part of Rolls-Royce, but they made huge, great diesel engines and turbines and pumps. And I had a fantastic apprenticeship, because part of the apprenticeship is you go around all the different departments and learn the different skills, from welding through to machine maintenance, through to turning and drawing office and all that kind of thing. And the company was later bought by Rolls-Royce. But I'm so grateful to have had that grounding in practical engineering. It really set me up.
So that helped you. And also you designed, was it candy vending machines for Mars?
Yeah, that's right. I went to Mars.
Went to Mars, the candy company. Yeah. The candy bars. Yeah.
That was just a reaction. I found, although diesel engines and pumps and turbines are fascinating from an engineering point of view, they don't have human scale. They live in a machine room. Whereas I'm more interested in design for humans more directly. And so went to Mars and designed vending machines. And that introduced me to the world of design. And in particular, the world of design consultants, because I went there as a mechanical designer, and Mars used these consultant guys, and I thought these were like gods. They came in and came up with the concepts, and then we followed the concepts. And I thought, hey, I want to do that.
Oh, so you're like, I want that job.
Exactly. I want to be the concept designer.
That's how life works. But a lot of people think that. Not everyone acts on it. You acted on it. But was there anything that we'd see in the Strida or one of your other designs that came from that experience at the candy vending machine?
I suppose the human interface of vending machines. How we design vending machines from the inside out. Working out the mechanism first and then think about the interface last, whereas we should have done it the other way around. We should have thought about the human interface and then make that drive the mechanics. But that's how the engineering world works. You kind of design the mechanics and throw it over the fence to an industrial designer to kind of make it work with humans. Sure. But it should be a continuum. It should be all done together. And I suppose that's what I learned from Mars.
Well, also, you mentioned Dreyfus earlier. That was one of his, Henry Dreyfus. In fact, just a little interesting thing. One of my most recent podcast guests was a student of Dreyfus. Byron Block was one of my podcast guests, focused on safety, design for safety, design of cars for safety. Byron was a student of Dreyfus. He's also my uncle, by the way, and the guy who got me into product design and mechanical engineering when I was heading to college. He's the one who got me interested in all this. But Byron has his own really fantastic career, and he was a student of Dreyfus. And so I'm just tying, you mentioned Dreyfus, just tying it back in. And so anyway, I think that's great. And then any other project you can tell us about that you're working on now? What's the next great thing coming from you, Mark, to the world? If you can talk about it. If you can't, that's okay.
Yeah, I've really I've designed a couple of electric bikes for big companies in Korea and in China. The last one actually was a really interesting project for the great big Xiaomi corporation, who make mobile phones, things like that. But they decided, instead of my project, they do the mega successful Xiaomi 365 electric scooter. So, wow, it sometimes goes that way. But as part of learning all about electric power, I've always been a car fanatic. Well, not really a fanatic, particularly Lotuses. And I always thought that, wouldn't it be nice to have a car that does all this stuff, but in silence, and also for free, powered by my solar panels on my roof? And so during lockdown, actually, I converted an old 50-year-old Lotus Elan to electric.
It's so cool.
And the thing is, what my mission was I was keen on doing electric. It was the second car I'd converted, but I wanted to, because everybody said at the time, we're going back, 3 or 4 years ago, electric cars, they're fast, but they're far too heavy. They'll never be fun and all this kind of thing. And I thought, no, I think they can be fun if you make them light enough. And so a lot of the exercise was juggling the numbers to get the range, the speed, and also keep the weight under its standard weight. And it ended up being 20 kilos you know, sort of, what's that, 40 pounds lighter than the original Elan.
Amazing.
So,
Amazing.
and that's led me on to dream about not my current project, but my next project, which would be a microlight powered by electric.
A microlight electric.
Yeah, because in the UK we have this fascinating rule, which if you can make an aeroplane which weighs, and it's a bit of an ask, under 70 kilos, you don't have to have a license. Obviously, it makes sense to have training, but you don't actually have to have a license, and you don't actually have to have the aircraft certified. And so,
wait, is that a good idea? Because sometimes things you can do doesn't mean you should do them. But
I've got some, you know, flying experience. So,
okay,
but I wouldn't recommend. I mean, everybody says you obviously must train for this. In fact, you've got to train to get the insurance anyway. So you'd be really stupid to fly without training. But the plan for that, the dream at the moment, starting to plan it out, is to make a sub 70 kilos airplane, basically. And
a sub 70 kilos airplane.
Yeah.
Well, I mean, that's crazy. That's wonderful, actually.
I know, it's crazy.
An electric? You're saying electric plane?
Yeah. And the initial one will be petrol powered to test the aerodynamics and things. But then going over to electric will involve, you know, juggling the weight of the motor, which is much less than a petrol motor, but with the weight of the batteries, which are much higher. But it's all a matter of juggling range, speed, and power and weight.
Well, it'll be amazing to think that I would love to see that aircraft, and amazing to think that you're still working on great products that can really touch and change people's lives and change our, in the case of this plane you're working on, our sense of even what's possible. And so you can learn more about Mark's company, MAS, at mas-design at .com. And I also want to invite you to listen to other episodes, our audience, to listen to other episodes of Masters of Engineering, or subscribe at Apple Podcasts, Google Play, Spotify, wherever you like to find your podcasts, or on YouTube for the video feed. Also, we love hearing what you think of these podcast episodes. So make sure you leave a review and tell me what you thought of Mark and his story. If you want to get in touch with me, you can follow me on Twitter at @jhirschtick. Mark, thanks again for joining us and for inspiring us with the Strida and all the other stories that you had here today.
My pleasure, John, and a real honor. I'd actually love to interview you about your career and some of the tools that you've given us. But maybe that's for another time. But thanks so much.
You know, really someday. Good. Oh, thank you. It's coming from you. It's a real honor. Maybe someday. But the joy of the tools I build, the CAD tools I build, is really in seeing the products that you build with them. So that's what's exciting. But thank you very much. Very kind of you. To our audience, that's it for today. See you all next time on Masters of Engineering.